I submit that there is an easier way to deal with them. That if you think about it, it makes perfect sense. Now, most of you probably found the surface area of this. Then you found the surface area of this. And then you did those two surface areas added together, and then you subtracted out two overlaps. And the overlap would have been this square right here. Is that what most of you did if you did this question? Right? You did, right? Now, that's fine. It works, but it's a lot of writing. I want to show you this. No. That's not what I want to show you. Everything I have colored blue is almost the same as this, isn't it? So everything blue, if I were to do the surface area of everything blue, I could do surface area equals 2 WH HL LW, couldn't I? And that would give me all the blue stuff, yes? Then, how many green shapes were added? 4. 1, 2, 3, 4 on the other side. So then you never have to worry about overlaps. Do you understand what I'm saying? It is significantly less math to do, but you will get to the same answer. Do you understand what I'm talking about? The blue, you already know how to do in one shot. Then all you got to do is add 4 greens. Then you're not worrying about overlaps. Everybody with me? So the blue is 2, 12 times 4 plus 12 times 4 plus 4 times 4, which is 48. 48 is 96, and 16 is 112 times 2. The blue is 224. And the green is 4 by 4 by 4, right? Which is 64. So the answer is 288. Now, please notice how little work I did on that. Did I do anything mathematically different than you did? No, I just found some surface areas and added them together, yes? Did I do less work than you did? Most likely. Does everybody understand? Do I care if you go the long way that you learned in grade 9? No, I don't care. But as the shapes get more and more complicated and more difficult to deal with, the less you got to write out and think about, the better off you'll be. Do you understand what I'm saying? That's why I spend so much time talking about why things work, so you can make up your own shortcuts. Everybody good? All right. Let's turn the page over. This one was 144, I believe. Do I need to go over how I found that? That has no formula, does it? It's a prism, but it has no formula, yes? So all you got to do is add up all the sides. There's this yellow side, and there's 2 of them. There's the blue side, and there's 2 of them. There's
yellow sides are identical.
The green side, yeah, of course. The green side, how many of them are there? 1. There's this purple, how many of them are there? 1. There's this rectangle up here, which is on this side of the triangle. How many of them are there?
2.
Only 1. Right? That's this rectangle that we can't see. And then finally, there's this triangle. How many of them are there? 2. So all you do is you find them all and you add them up. Now the only trick here was you didn't know this distance, did you? But you did know it because this part was 3 and this part was 4. So you did Pythagoras and you found that to be 5. and then you were good. Right? Because 3 squared is 9, 4 squared is 16, 16 and 9 is 25, square root of 25 is 5. This is a very powerful form to memorize. Okay? 3, 4, 5, 6, 8, 10, right? 9, 12, 15. The 3, 4, 5 triangle is a very important triangle just to have in your mathematical toolbox. All right? Kind of like how you all know the square root of 4 is 2. The 3, 4, 5 triangle is a good one to just, oh yeah, I know how that one works. Everybody cool? Okay. Then this one, surface area, again, you really just have to add it all up, right? How many of them are there? Come on. Who has an answer for that one while I wait?
387?
Just guess one. 387?
Probably wrong, but that's good.
So we got to guess a 387. So this guy, there's how many?
75.
There's 2. This guy, there's how many? Times 2. This guy, there's how many? Times 2. This guy, there's how many? 2. Oops, that was a bad color to use there. 2. Right? That's everything except what? The bottom underneath. Then you just add it all up. Now, this triangle, some of you will say, oh, Mr. Myers, I don't know the base and height of that triangle, but you do. Because if I turn it this way with a 90 degree, 5 and 5, you do know the base and the height. Everybody good? Any questions? So, 5 and 5, so that's 25, and 8 and 2 is 16, so that's 32, and 5 and 15 is 75 times 2 is 150, 15 times 2 is 30, so that's 60, and the bottom is 8 times 15, which is 120, so it's calculators or computer stuck. 120 plus 110 is 230 plus 110 plus 64 plus 25 is 9.
Why did you write it as 32? It's 8 times 2, which is 16. It's 32.
But there's 2 of them.
Yeah, so it's not 32 times 2. It's not 64.
Oh, right. I wrote 64. Thank you. 32, 7, 2, 3, 6, 8. Carry the 1. Yep. No 8. The 8 doesn't carry. 2, 3, and 5 is 8. 287. Oh, yeah, 287.
Did you add the one underneath as well?
1, 1. 1 plus 1 is 2. Where did I get another 1 from?
I meant the rectangle underneath, because I'm not sure.
There's the 120. There's the rectangle underneath, 8 by 15.
Okay.
110. That's 50. Oh, that's 150. Idiot. 150. Yeah. I added that up wrong. Because I wrote it weirdly. I did the same thing here where I multiplied that. Anyway, I'm not concerned about the answer. I'm concerned about how you get it. So let's come back to that in a sec when my computer thaws. Because it's a piece of garbage. So let's write this out slowly instead of talking about it. 120 is the bottom. The 2 sides are another 60. That is 150, 32, and 25. 7, yeah, there we go. 2 and 6 is 8, and 5, 13, and 5 is 8. Yes, 387, you were right. I didn't have that 150. I put it as 50.
Yes, I do have a brain.
Okay, this question, again, just like the first one we did, are you able to split it in half and minus your overlaps?
Yeah.
Okay, but if I do this, 22, 6, and 4. This thing that I drew here is almost exactly the same as this, yes? What's the only part that's added? See how this rectangle is not there? But I have put it in this one. Is everybody with me? So if I find this surface area, but I subtract out that green rectangle how many times? Twice, because it's missing at the back and it's missing at the front, right? If I minus that times 2, will I have my surface area? I will. And it is significantly less work, again. Because this thing I drew here is this, isn't it? Because if I draw in red, all that's missing is that rectangle, yes? The roof is still totally there, isn't it? And this wall is still totally there, isn't it? So the only thing missing is that little bit of green and that little bit of green. So if I do this one as a whole prism, I get 400. I can't remember what I get. I get 2 times 6 times 4 plus 22 times 6 plus 22 times 4. And I would add all that up, and then I would subtract this rectangle, which is 2 times 11, and there's 2 of them. Okay, so I think it's 488 for this one, and I subtract out 44 to get a final answer of 444, I think. And I can check that on the other class, because I've already done those ones. 444, indeed. If you don't have 444, but you have used the right formulas, all you have done is made a mistake with your calculator. What is more important to me? Fat fingers or doing the math right, writing the math right? Writing the math right. Everybody makes a mistake when they're texting. It's no big deal, right? I sent a guy a text today that said I was fit as a fiddle, but I typed fit as a fiddle, didn't read it, and it autocorrected to 4 as a fiddle. The guy knew what I meant. So that's that one. And then the back page. Surface area of that was pi r squared, 2 pi r squared plus 2 pi r h, 2 pi times 3 squared plus 2 pi times 3 times 8, which is 18 pi plus 48 pi, 18 pi plus 48 pi, which is 66 pi. If you didn't leave it as 66 pi, you can't do that. You're just like, no, I refuse to leave it as 66 pi. You did 66 times pi button, and you got something like 180, something around 100 and something around 200. 207? Great.
Is it okay if we do the times by pi in the very beginning?
I don't care. I don't care. This question, if you did it wrong, that's okay. Almost the entire pre-dip class also did it wrong. When you read the question, what do you see? Gallons, feet. What did I measure my room in? Meters. So what's the problem? I got to do some converting, yes? I need to convert those meters to feet, don't I? So 4.1 divided by 0.3048, 5.3 divided by 0.3048, and 3 divided by 0.3048. And you get something like 13 17 and 9 something. I don't know what. I can't remember. So now I've got it all in feet, yeah? When you're painting a room, what do you paint? Walls only. How do you find the area of the wall? It's along the bottom and up the height, right? So one wall was 13 times 9-ish. Yes? What?
Since it's talking about the entire room, could you have done the surface area of the whole room before in meters before converting?
Yes, you could have, but then I guarantee you converted it wrong. I don't guarantee it, but I'm 90% sure because everybody converts that wrong, and I'm about to show you why. So it's about 13 by 9, yes? And how many walls are there of that size? 2. And the other wall was 17 by 9 times 2. Everybody with me? And when you do that math, you get approximately 608 feet square. What do you have to do with that to find out how much paint you got to buy? What? What do I got to do with my, how much? That's how much I got to paint. How do I figure out how much paint I got to buy? The answer is always add, subtract, multiply, or divide, guys. You got to. No. You've got a 25% chance of hitting the right one. You divide by what? 300. And you get 2.02. What a pain in the ass. How many gallons of paint you got to buy? 3 gallons. So you end up painting your whole room and using like 2 roller dips to finish that last little corner. Then you got a whole can of paint that sits in your garage until it's no good anymore. At least, I don't know about you guys, but that's what my garage looks like. There's a corner filled with paint. Because you paint a whole room and you leave like that much, and damn! You got to go back to Home Depot. Super pain in the ass. Now, Aiden asked a question, could you do it all in metric and then convert? Sure. You would have had 4.1 times 3 times 2, correct? And then 5.3 times 3 times 2. And when you added all that up, you ended up with 56.4-ish, right?
If you did it properly.
Yeah, if you did it properly. 56.4 meters squared. Now, how do you convert that to feet? Because you need feet squared, so what do? Why are you looking at me quizzically? Same thing as before. Excellent. You multiply it by what fraction? 1 foot over 0.3048 meters, yes?
Yeah.
So you do 56.4 divided by 0.3048 to get feet, correct?
Yeah.
And when you do that, what do you get? You did it that way, didn't you? What did you get? 185 square feet. But we know it's got to be 607, don't we? Here is where you went wrong. Did anybody try and do this, by the way? Keep it all in meters and convert at the end? Nobody except Aiden? I'm going to show you this anyway, because this is a mistake kids make all the time. If that's 1 foot and that's 1 foot, how big is this inside? 1 foot squared. Agreed? Everyone agree? Okay. Convert that to metric. 1 foot is how many meters? It's 0.3048 meters, isn't it? What's this one? 0.3048 meters, yes? How do you find the area in there? 0.3048 times 0.3048, yes? So it's really 0.929 something. So the conversion changes. Why? Because you need to convert length and width. So if you're going from a linear measurement, a line, to a squared measurement, you have to convert it twice. So 1 foot equals 0.3048 meters in a straight line, yes? But this is an equation, isn't it? 1 foot equals, yes? So if I go to 1 foot squared, what did I do to this side of the equation? I squared it, right? So what do I have to do to this side of the equation? Square it. So 1 foot squared is 0.3048 squared. Everybody with me? And this is why it works. Everybody cool? I just want to show you a metric example of it because it's easier to see with metric. If that's 1 meter and that's 1 meter, what's this? 1 meter squared, yes? If this is centimeters, how big is it? How many centimeters are in a meter? 100, right? How many centimeters are in this meter? 100. So this is 10,000 centimeters squared. Because it would be 100 centimeters this way and 100 centimeters this way. Does everybody understand? 1 meter equals 100 centimeters in a straight line, but 1 meter squared equals 100 squared centimeters. Everybody cool? Now, just out of curiosity, if you did what Aiden did, you kept it all metric, but then you screwed up the conversion at the end, what do you think I would give him? Because I never showed you guys this before. This is something he would have had to figure out on his own, even though there's nothing special here, is there? It's just common sense. 1 by 1, oh, I got to convert both of them, right? What do you think out of 4 should I give Aiden for the way he did it? 3.5? But his answer was totally wrong. 1 shows very little understanding. He understood that he had to find the area of the walls. He found the area of the walls in meters, but then he screwed up his conversion. So, he'd get a 2 out of 4, wouldn't he? Everybody with me? You understand what I'm saying? And I'm not trying to put you down, Aiden, right? This is just the way you guys are going to get assessed by the time you're in grade 12. I'm just trying to get you prepared for it. Okay? Now, a lot of previous math teachers, if you said 185 square feet there, would have just said it was totally wrong, right? Because it was way off. Everybody with me? I'm not like that. That's not how I wish to assess you. Are you all cool with this? You don't have to agree with it or not. You just need to understand that that's kind of where we're going. Yeah? Okay. And I think that was the last question, yes? All right, if you would be so kind as to turn the page over and then close your book. Well, don't close your books, just look away from them. Look up at the screen. But even though the screen is showing my microphone, I don't want it to show my microphone. I want it to show that. That is weird. That's a pink block. But on the screen, that don't look no pink. Let's try zooming in and see what happens. Still looks white. That's crazy, hey? What does a white block look like? Will it look pink? Shade it, it will look pink. Oh yeah, look at that. What if I turn the light on? Oh, well now it's pink down in the middle. Weird. Anyway, okay, let's talk about how this helps in math. We have talked about surface area, yes? Can any of you tell me the surface area? Pretend that there's no little hole drilled in it and this little nubbin isn't there. Can any of you tell me the surface area of that thing? You don't have measurement, so you have to give it a unit, yes? How wide is it? How many of these are there? 1. Right? So it's 1 this way. How long is it this way? 1. So the surface area of this face that you can see is 1 cube squared, yes? Everyone agree? Surface area of the whole thing, how many faces are on it? 6. So this is 6 square units of space. Is everybody cool? Everyone agree? Okay. Now, you guys are smart kids. Right now, you can only see one of those units, yes? If I hold it up away from the camera, you all see, oh, it's a 3-dimensional thing. So now I know that it's got 6 faces, so its surface area is 6, yes? Right? Moving on to volume. Volume is how much space something takes up in the universe. How much space of the universe is this taking up? A little bit. Do you know how much? No, because you can't measure it, so we have to give it a unit. This is 1 cube, yes? So this is taking up 1 cubic unit of space in the universe. Is everybody with me? Because it's only 1 cube. Everybody cool? Yeah? Okay. Now what do you see? What do you see? You see 9, yes? Everyone agree? Okay. You see that there are 9 cubes visible to you. So you can tell me the area of that is 9 cubes, yes? Everyone agrees? And on this screen, it is indeed only 2 dimensions. So it's stuck at being 9, isn't it? Now, if I hold it up, you can all see how thick is this? No. We can't give it, how thick is that? 1 cube. So we saw that it was 9.
So its volume is...
Right? And it's 1 thick. Agreed? So that means one of them had a volume of 1. What's the volume of 9 of them? 9. Is everybody with me? I see 9 in area, and I know that it's repeated once this way. So this gives me a volume of 9, correct? Everyone agree? I'm going to turn it sideways. How much do you see now? 3. So the area you see is 3. How many times does that repeat? 3 times, giving me a volume of what? 9. Exactly the same, no matter how I twist it. Everyone cool? Okay, now. What do you see? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Agreed? How thick is it? 1. So what's the volume? 9. Everybody with me? Whatever I saw multiplied by however thick it is gave me my volume. So if I know the area of one part of it, and that repeats a second time, it's the same shape, isn't it? So this we know to be 9, yes? What if I told you there was another one underneath? What's its volume now? It was 9. Now there's a whole second one underneath. So what would it be, Dakota? Or Sade? Somebody said it.
18.
18. Why?
Because there's 2 sets.
Because I took this 9 and I repeated it a second time. Does everybody understand? What would you call this? Is it the base shape? If I stack this up 3 times, does that shape repeat?
Yes.
So does that make this the base shape?
Yes.
So what does that tell me? If I know the base area, 9, and I know how many times it will repeat, what will that give me?
The volume.
The volume. When?
What do you mean when?
When in the universe is the base shape multiplied by the height always I just gave it away. Always. Because no matter what shape I make this, when I took it back to this,
Only when it's written.
I had the same volume.
Only when it's a prism, though.
Yes, only when it's a prism. Thank you. Is everybody cool?
Yes.
So, volume deals with the amount of space an object contains. So back to our books, please. Now, volume is a little weird because we use volume and another word that is similar to it, capacity. We use them interchangeably. Quanta has a water bottle there, yes? That water bottle is probably a liter in capacity. Is it? It doesn't say on the side? Yeah, right there. So it'll hold a liter of water, yes? So is its volume 1 liter, or is its capacity 1 liter? Capacity is 1 liter, because volume is the amount of space it takes up, yes? And volume would have to include the handle and the lid. Does everybody understand? A bottle of Coke holds 541 milliliters of Coke. Its capacity is 541. But its volume is slightly more because the bottle takes up space. Everybody with me?
The physical material.
Yeah, volume is everything. Capacity is what'll fit inside. Okay? We use them interchangeably in math class. It's okay. Is everybody with me? All right. So, volume of a prism. What did we just find out? We just found out that it was the area of the base multiplied by the height. Now, in that formula, there's 2 words that are a pain in the ass. What are the 2 words that are a pain? Base and height, yes? Because where is the base of my coffee cup? The bottom, right? Where's the base? Now it's the circle. So base, we remember, can be the bottom, but it can also be the repeated shape, yes? Which one do I mean here? The bottom or the repeated shape? I mean the repeated shape, don't I? Remember that upside down pyramid I showed you? The base was on the top. So the area of the base, this is the repeated shape. So it may be a rectangle, it may be a triangle, it may be a circle, whatever, yes? Now, what's the height of my coffee cup? Where would you measure the height, Mason? Where? Where on this would you tell me the height is? Right up here, yes? Because it's going up and down, agreed? Okay, what if I turn it this way? Now what's the height? As Ryan says, it's this. And he's right, isn't it? This is the height, yeah? What if I turn it this way? What's the height? What if I turn it this way? What's the height? Evan, that's grody. Everybody cool? So, once again, height, we say height, but what we really mean is the direction the shape repeats. Does everybody understand what I mean? You choose the basic shape, which in this case is the circle, and whatever direction that circle repeats is the height. Is everybody cool? Yeah? Okay. That's a prism. What's the other thing we've looked at? Pyramids. So I better know what happens when I'm dealing with pyramids. Now, you guys are smart kids. What's the difference between a prism and a pyramid? I lie. Let's change that question. What's the same about a prism and a pyramid? They can share a base, yes? They both start from a shape. Agreed? Excellent. Does that shape repeat? Yes. So we know the height is also shared between the two of them, isn't it? So I know a volume of a pyramid must start with an area of a base. And what is that base? Is it the bottom or is it the repeated shape? You're just saying both of them, Mason, until I say yes. I'm going to keep looking at you without nodding or shaking my head until you make a decision. Is it the bottom or is it the shape that repeats? Perfect! Nice job! It's the repeated shape. And then the height. What's the height? Is it up and down? Or is it the direction that the shape repeats? It's the direction the shape repeats. Now, here is where you must be smart. There is a shape, yes? Everyone agree? If I want to turn that into a prism, I must repeat that shape, yes? And I'm going to repeat it upwards. Does everyone agree? So where is the shape that I started from? It's at the bottom, which makes it both the base shape and the base. Agreed? And what direction did I repeat it? Up. So the volume of this would be this green amount, this multiplied by how far I went up. Correct? Everybody agree? Just one sec. Don't give me away. Does everyone agree with me here? So if I told you this area down here was 6 centimeters squared, and I went up 4 centimeters, what would the volume of that thing be? Area of the base, 6, times the height, 4. Is everybody cool? So it would be 24. Is everybody good? All right. Now, if I make this a pyramid, then I'm going to start with this same bottom, aren't I? It is still 6 centimeters squared, yes? And then I'm going to go up to the top. Now, you guys are smart kids. Is the height the same? So I still repeated 4 times, didn't I? But volume is the amount of space something takes up, yes? What is happening here, 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 here? Is any of that space being taken up? Or does it look like this? Damn it. That's what it looks like, yes? So what has happened to my volume? Is it bigger or smaller? It's smaller. And through experimentation, geometrists realized that it was exactly, always, no matter what, 1/3 of its prism, its related prism, no matter what. So, the prism I drew was 24. What is the pyramid that comes from the same bottom worth?
So two-dimensional area.
Exactly. The prism was 24. The pyramid that starts from the same spot and goes to the same height is 24/3, which is 8. Does everybody understand? Great. Now, you see how this says go back to the previous 5 questions and let's do volume? You have 4 questions. The 5th question is coming out of your assignment. So everybody turn back to the Matteo's question. We already did surface area. We found it to be that. Right? Uh, 26 maybe? What page is it, guys? 27? Okay. That's what we're dealing with, yes? Everyone agree? Okay. Now, if we draw it this way, Matteo's, where would you say the base is? You want to say it's the bottom, and that's cool. So the bottom is that rectangle right there, correct? Does that rectangle repeat? Which direction? Up. So if I know the area of the base and I multiply it by the height, I must get the volume, correct? What's the area of the base?
192.
Don't tell me what it is. Tell me how to find it first. Sorry.
Oh,
My fault.
24 times 8.
24 times 8. What's the height?
40.
40. Everybody agree? Okay. What if I turn it on its side and I tell you this, the yellow is the base? What's the area of the base now? 40 by 8 by what? 24. What if I tell you this in the front is now the base? What's the area of the base? What would it be? 40 by 40 by what? 24 by what? 8. Does any of that order matter? Why? Because it's multiplying. Is 5 times 2 the same as 2 times 5? All of this will give me my volume, which gives you the formula that your grade 6 teacher gave you for volume, which is LWH, right? I don't like giving that formula because that only works for rectangular prisms. Are there more prisms in the world than rectangular prisms? Yes. So should we stress the formula for rectangular prisms? I don't think we should. Because what always works? Area of base times height. Always. Whether it's a cylinder, an octagon, a nonagon, a dodecahedron. Okay? And when we do that math, we find the answer to be 320 times 224 is 6,400 and 120, 1280, 7680? Yeah. Centimeters cubed. Everybody cool? All right. Turn the page over. We did a square base pyramid, yes? Hopefully you've got some blank space. The volume of a pyramid is what? It's the same as the volume of a prism up to a point, yes? It's the area of the base times the height. Height or slant height here? Which is it? Height, regular height, right? Because we're counting right up the middle. Divided by what? 3. So what's the base of this pyramid? Where is the base? What's the shape that's repeating? It's that square, right? So the area of the base is 32 times 32, correct? And how tall did we go? We're going to use 65 because it's written right there, right? We changed it to slant height, but we're going to use 65 there. Everybody cool? Times 65. And then what do I do with that whole answer? Divide by 3. 32 times 32 is 964 and another. Oh, man, I can't do that in my head. What is it?
Wow. 22,186.
22,186 feet cubed.
Well, that would be 0.66.
Yeah, whatever. Yeah. Everybody cool? It's still the area of a base, still times the height, but because it's a pyramid, we got to divide by 3. Let's go down to the cone. Is a cone a prism or a pyramid?
A pyramid.
It's a pyramid, so it must be area of the base times the height divided by 3, right?
So r squared.
So as soon as my computer thaws, still area of the base, still times the height, still divided by 3. But our base is now weird. What's our base? A circle. How do I find the area of a circle?
R squared.
Pi r squared times the height divided by 3. Pi, what's my r in this question? 15 squared. What's my height? It's in the question. 22. No, 22 wasn't the slant height. 22 was the height. Divided by what? 3. So you're going to do all that math, and you're going to come up with 15 squared is 225. 225 times 22 is 4,000. I didn't do this question earlier because we just wrote out the equation. 225 times 22 is not 5,183.
15 squared times pi.
Don't do pi. 15 squared times 22 is 4,950.
So we're not doing the
Divided by 3 is 1650 pi. Because we want to leave pi in there.
we do.
Yes. Because that's the exact answer. Anything else is the best guess you can give. Now, if you are like Aiden and you can't leave that, it just makes you go, you wouldn't want to see me when I'm angry, then do 1650 times pi. And you'll get an answer of about 5,000 and something. If you really have to. Who knows what I meant when I said you wouldn't want to see me when I'm angry? Who am I speaking of? I know, that's why I did it. But Hulk from the TV show, because I don't think he ever says it in the Avengers movies, does he? He has said it? Okay. Hulk is a mess for me, because there was that Hulk movie from like 1994, which was weird and crazy, and the Hulk was all like existential and like, what is my motivation? And then there was that other Hulk movie where he was just, Hulk smash! And then there's the newest Hulk that's in the Avengers movies. And then if you read the comics, there's another Hulk where he's gray and he's not crazy. He's all normal. Hello, William, how are you? But he's still Hulk, if you read the comics. And then there's Red Hulk and Purple Hulk. Hulk is crazy.
Wasn't there like a Venom Hulk?
Yeah, I think there might have been a Venom Hulk. I've lost track. Because I'm a bit of a comic book nerd. Strike that. I'm a bit of a nerd. I'll just leave it at that.
Do you watch Doctor Who?
Of course I watch Doctor Who, but I stopped watching Doctor Who when David Thewlis became the Doctor because I liked Christopher Eccleston. And I don't like the new woman Doctor, and it's not sexist, I just don't like her. What is sexist is when I watched the original, well not the original, but the newest original with Christopher Eccleston as the Doctor, and Billie Piper Rose, I had a bit of a crush on Billie Piper. And sometimes I watched it for her. I'm not going to lie. But I did prefer Christopher Eccleston. He's my favorite Doctor ever. From even back in the movie, like back in the old Doctor Who's from the 70s. Yes.
He's very sassy.
Now, last one. Cylinder. Prism or pyramid?
It's a prism.
It's a prism. So it must be area of base times the height. Do I have to divide it by anything? Nope. But the base is what? Circle. So it's pi r squared h. Pi, what's r? 5 squared. What's h? 20. 5 squared is 25. 25 times 20 is 500 pi. And if you can't deal with that, it's about 1,600 and something when you multiply it out.
1,570.
1,570. Pretty darn close to 1,600. Is everybody good? All right, now we've done 4. I said we were going to do 5, yeah? The 4 are easy. Does everybody understand? All it is you decide the shape that's repeating and you multiply it by whatever number is the direction of the repetition. Does everyone agree? Okay, now turn your page over 1 page back to this guy, our friend.
Oh no. Please no. Not him. Not that one. Please. Please, Myers, no. Please.
How many of you would want to do this? Cut it in half, find this volume, which is LWH,
And just add.
then find this volume, which is LWH, and then add them. Would that work?
Yes.
Yes. Now, let me ask you this. Does that shape repeat? So what does that make that? The base. So if you found this surface area and multiplied it by what? 4, you would get the volume. Does everybody understand?
Yes.
So let me ask you this. What if it was a weird shape?
Oh.
It would still repeat going back 4, yes? So you don't have to get all crazy. If you can find that area, what are you going to multiply it by to find the volume? 4, Elijah. Yeah. I know what you mean. Everybody with me? No matter what shape I have here, as long as that shape repeats, I can use that volume formula. Formula. Everybody understand? Even if it's an ugly shape. Right? Like that lightning bolt that I put under the screen. As long as I knew the lightning bolt, as long as I know how many times it repeated, I could find the volume. Just like here. Everybody good? All right. Now, class is about to end. Listen to me carefully. Do not do any math tonight. Yeah, it's a real easy day for that. If I check homework tomorrow, everyone will get a tick because nobody will do it. Okay? We did not. It's a short day, and I wanted to go through the theory of this before we get into spheres because spheres make no sense. You can't build them out of blocks. So tomorrow we'll finish spheres and you'll do an assignment that covers all of volume. Now, let's talk. Just let me stop recording because this is personal.